How did AlexNet revolutionize science at ImageNet 2012? Imagine a computer recognizing images with the accuracy of a human. That was the breakthrough achieved at the 2012 ImageNet Challenge, thanks to a new kind of neural network called AlexNet. This model changed everything in the world of convolutional neural networks, which are a special type of deep learning architecture designed for images. Before AlexNet, most image recognition systems struggled with accuracy and speed. But AlexNet proved that deep neural networks could handle large, complex datasets and do it quickly. It achieved a top-5 error rate of just 15.3%, way better than the second-best entry, which had an error rate of 26.2%. That huge difference showed that deep CNNs were not just a theory anymore but a real tool for real-world tasks. What made AlexNet so special? First, it had 8 layers that learned from images, 5 convolutional layers that picked up on features like edges and shapes, and 3 fully connected layers that combine these features to recognize objects. This deep structure allowed it to understand images in a way that shallower networks could not. Second, it used ReLU activation functions, which are simple but powerful. These functions sped up the training process by making the network learn faster than traditional sigmoid or TAN functions. Third, AlexNet was one of the first CNNs trained on graphics processing units or GPUs, specifically to NVIDIA GTX 580 cards. This hardware boost let it process the huge ImageNet dataset of over 1 million images in just a few days instead of weeks or months. Another key factor was its use of regularization techniques like dropout, which randomly turned off some neurons during training to prevent the network from overfitting. It also used data augmentation, meaning it transformed images by cropping, flipping, and changing brightness to make the training set larger and more varied. These tricks helped AlexNet become more accurate and more robust. The success of AlexNet showed that combining large datasets, powerful hardware, and smart training methods could produce incredible results. It inspired many new CNN architectures like VGGNet, GoogleNet, and RaiseNet, which built on its ideas to push accuracy even further. From the perspective of artificial intelligence and machine learning, AlexNet was a turning point. It proved that deep learning could solve complex image recognition problems efficiently. This opened the door for many modern AI tools, including image generators like DALL-E and Midjourney, which relying on deep neural networks to create images from text prompts. But it also raised questions about the resources needed for such models, like large datasets and powerful hardware, which can be expensive and environmentally demanding. Understanding these factors is important as we develop smarter, more accessible AI systems. In short, AlexNet revolutionized CNNs by showing that deep neural networks could excel at large-scale image recognition. It introduced new ideas in architecture and training that set the stage for the rapid growth of AI applications we see today.